Hi, I'm James Lehman, and I'm the guy that wrote LaserBoy. LaserBoy is something that I started on about 17 years ago, and at the time it was just some code that I put together in order to complete a project that I had in front of me. And that was to make a laser show for First Night Akron 2004, which is the New Year's Eve celebration. And I had about 2 months to do it. So I'm a Linux programmer, and I had already spent a considerable amount of time working on another project called EZFB, which is an API written in C that gives a programmer complete access to the video card in a Linux machine. It gives you the RAM, you can put images directly into the RAM, and you can control what's on the screen in real time. So writing code for Laser was actually something that worked really well for me at that time because I could use my EZFB frame buffer API along with writing the code that would become LaserBoy, and the two of them worked together very nicely, and I was able to develop both of them at the same time. Well, it turns out that the way memory is stored in a video card that puts the picture on the screen is pretty much exactly the same way as an image is stored in a bitmap file. It's just one's in the memory in the video card, the other one is you put a header on it, store it to a file, and you have a bitmap file. So I had quite a bit of code that knew how to deal with bitmap files, reading them and writing them and managing them and drawing pixels into them and lines and so on. So I used that capability to build LaserBoy. And originally LaserBoy was actually a console application. I would have two computers. One was running Linux with a high-resolution video display with my frame buffer API controlling the video display. And then another computer I would use to shell into the Linux machine at a command prompt or a terminal, and I would issue my commands in the command prompt and make the high-resolution video display show me what I was working with. So first thing I did was I wrote code that made it possible for me to open up the contents of any ILDA file. And an ILDA file is a set of frames. Each frame is a vector image, which might be color, could be two-dimensional or three-dimensional. The color might come from a palette or it might be direct RGB. And there can be any number of frames. Typically these frames make some sort of an animation. And the code that I wrote made it possible to open an ILDA file into the memory of the computer as a rather complex memory object. It could contain all of the frames, it can contain all of the palettes that are associated with those frames, and it gave me the ability to, well, have a state machine, which is once the data is loaded into the memory, it just sits there until you want to do something with it. And when you do something to it, you make some sort of incremental change to it, it becomes something else. So it's a static representation of an animated set of frames. It kind of exists outside of time. It's a very complex memory object. And when I had that, I was able to load anything that was already an ILDA file into the memory and use that as a starting point to create animations by moving elements around in a frame or whatever the case may be. And then I was able to save that information as an ILDA file and open it up. And at that time, for the First Night Akron 2004 show, we were using a proprietary a proprietary laser controller card. It was actually an ISA card slot. And we recorded the output of that onto a modified ADAT machine. And that's when it all kind of made sense to me. That's when I fully understood what laser signals were all about and that you could use an audio device to record them and play them back. So after the First Night Akron show was done, I just decided that I would continue working with this new art form of color laser display. And I knew, since I used an ADAT machine, that I was dealing with audio-like signals. So I extended the capabilities of the code that I had so that it would be able to read and write multi-channel wave files. And those multi-channel wave files could contain the optimized laser signals, which when sent to the projector would actually project the show that you'd created in a frame set. So for this whole wave idea to make sense, well, I knew I needed a piece of hardware that would be able to do that. So I looked in the Linux kernel driver, the kernel build configuration tool in the sound devices, and there were a couple of chipsets that were listed there that were 6-channel or 8-channel capable. So I looked for devices that had those chips on them, and I should say, started modifying sound cards and experimenting with the idea of making this work. And when I say we, I mean my friend Dean Hammonds and I, somebody that I've known since I think 6th or 7th grade. Anyway, he's pretty good with electronics and op amps and all that kind of stuff, and he came up with a very simple, very straightforward op amp circuit that could be used to compensate for the DC offset and provide gain to bring the voltage of the signal up to something that's compatible with a laser projector. So we started with his original design, and over a period of several years, things were modified. I've worked on it since then, and I came up with a circuit board that I printed. This is a LaserBoy DAC in that this is a USB sound device that's designed for surround sound. It's actually an 8-channel, 16-bit, 48 kilohertz DAC, and I tacked wires onto the DAC side of all the capacitors that block the DC from the analog outputs, and then I bring those signals into a correction amplifier, which is a few generations later than the original design that Dean Hammonds drew up back in, what was it, 2004, 2000, yeah, it would be sometime in 2004. But anyway, this is a LaserBoy DAC. It's still a sound card. I mean, that's exactly what it is. It is a sound card, and all of these jacks still work because they still have the capacitors in series with them, just like they should. But it also has an ILDA port on it, and you can use it to produce laser signals. LaserBoy actually defines a couple of file formats that are extensions of already existing file formats, and the whole idea of all of that is to keep it open source. It extends the concept of a WAV file. A WAV file is written as a chunk file system, which means that each chunk of a file has, there's a specific place where you find the size of the entire chunk so that you can skip the chunk if you don't know what it is. Which means you can add things to a WAV file that won't affect the ability for any other application to be able to read the WAV file and make use of it. So I use that to add information in the header of a WAV file that basically describes some things that you need to know in order to use that WAV file as a multi-channel signal set for laser control with X and Y, RGB, and possibly other things stored in the 6th channel or even the 7th and 8th channel. I also used binary markers in the color channels because the RGB channels you're only storing 256, you're storing 8 bits of information in a 16-bit number in a WAV file. So you have the least significant bits in the RGB channels to use to do something with, to mark something with. So I marked using the red channel, the least significant bit in the red channel designates the end of a frame, and the least significant bit in the green channel designates whether or not the frame is unique or has been repeated. And these things are actually stored in the LaserBoy formatted WAV, so that if you create a WAV file in LaserBoy and save it, then when you open it later from LaserBoy, LaserBoy knows how to read those format marks and can give you a completely framed set. I'd have to say it's just not possible for me to tell you what LaserBoy is in 30 minutes. I mean, if you download the application and you run it, and you take the time to explore what's in there, you'll get a sense of what it is and how much you can do with it. A lot of people think the user interface is a little weird, and I guess it is, being that it's all keyboard, but that's because LaserBoy started as a console application that would run in a shell, and the shell was connected to a Linux machine that was giving me the high resolution vector display. So the only thing I had to work with was a keyboard. And so as I was developing the code in the early stages, it wasn't for anyone in particular other than me. So I wrote menu systems, and I could keep the menus, show the menu in the terminal, and I knew what to hit next in order to make the LaserBoy core code, the memory object, do what I wanted it to do. Open file, save file, modify the contents of a file in the memory somehow, change the colors in the file, whatever it did, and save it, and then you were out, and you could use that ILDA file for some other purpose then. So I just kept developing it that way, and it kind of became a challenge to do it that way without using a mouse. And that's when I kind of discovered that there's a level of precision that you can achieve by using a keyboard as opposed to a mouse, because a mouse has the resolution of whatever the display is that you have on the screen that you can see of that vector set. But a keyboard, it has nothing to do with the resolution of the display that you see on the screen. The keyboard simply counts iterations of how many times you've hit a particular key. And that made it make sense to me that LaserBoy is a memory object, so it is a state machine. So an individual incremental change to the state machine could be achieved by tapping a key on the keyboard. And that's what LaserBoy does. It maintains whatever's in the memory for as long as you want it there until you want to change it in some incremental way. And you do that by tapping a key. Sometimes when you tap a key or a few keys, it'll ask you to type in a name of something or what have you. But for the most part, when you're working with LaserBoy, you're looking for a key in the menu system. There is some sense to whether it's the lowercase version or the uppercase version. There's also a logical sense when you're in certain menus. It's simply it's 0 through 9, and the alpha, A through Z in that order to choose something from the list. Sometimes it's logically the physical position of keys on the keyboard, because these 3 keys are in a row and these 3 keys are in a row. There's a lot of that is used. Sometimes it comes down to the logic use of things like X, Y, and Z on the keyboard, and left, right, up, down arrows and the delete key and the backspace key and that sort of thing. And the enter key is kind of weird, because the enter key typically makes the menus appear or disappear, unless in fact you're terminating when you have to enter a line of or string of text into LaserBoy at a prompt, and you hit return in order to enter that. But for the most part, the way the keyboard works definitely has sense to it. It is organized. There is kind of a zen to it. You do have to pay attention to context, because when you're in different menus, the same key might mean a completely different thing. So you really have to understand when you're in the main menu, or when you're in the color and blank and unblank and draw menu, or when you're in the move and scale and rotate menu, or when, various menus that you're in, the same key can do something different in all of those different menus. So you have to understand where you are in LaserBoy, and if you're ever confused, just start banging on the escape key until you see the screen flashing red, and you hit it one more time. When you see LaserBoy come back again, you know you're at the main menu, and from there you can go into any one of the menus where you think you ought to be, and then you know what the key does, because you can see, hit the enter key, you can see the key map on the screen, you can go, yeah, that's it, and you hit the key and use it. That's how LaserBoy works. It takes a while to get used to it, but when you do get used to it, it's actually very fast. It really is. If you put your mind to solving a particular task, and you, I guess, if you have to write it down, whatever you need to do, memorize a set of keystrokes, you can typically open a file and modify it in a very meaningful way and save it, in not that many keystrokes, and it doesn't take that long to do it. So if in the process of doing that you mess up and you end up with junk loaded in the LaserBoy's memory, you just start again. You open up the file and you do the same click, 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 going through what it is that you need to do to modify it in order to get it ready to save it, and you can get there. So, I mean, when you are using LaserBoy, there is no undo. You have to remember that for sure. So it makes sense to save your file in stages. You know, you create a beginning piece of art, and you go, okay, that's cool, that's where I want to be, and you save it. And then you modify it in some way, and you go, all right, that's another step, and you save that. Or you know you need to make a set of individual things, and you need to composite them together in some way. You have to save those things along the way, so that you have a set of files that are saved all along the way, so that you don't have to keep starting at square zero every single time you want to. You know, maybe you did something in LaserBoy that you thought, oh, well, I didn't want to do that. Well, you got to start over again. So you have to have the file ready. You just open it again, and you click, 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 click. All right, now I'm back to where I was. This time I'm going to do it a little bit differently. That's kind of how LaserBoy works. And the fact that it can only read and write into its own file space, well, it is an inconvenience. However, that's what makes it platform independent. It makes it easy for me to use Boost to write the code necessary to be able to read and write files on Windows or Linux or whatever, anything else that is pretty much supported by SDL2 and Boost. So yeah, I mean, it's kind of weird, but if you think about it, you could have an external USB storage device, and you could have LaserBoy installed on that. And inside the LaserBoy folder, you can have a version of LaserBoy, the executable, that'll run in Linux or Windows 32-bit or Windows 64-bit, or maybe on a Mac, hopefully soon, or some other operating system that, you know, maybe that you've never even heard of, that is supported by SDL2 and Boost libs, the Boost C++ extensions, and you can just plug that USB drive into whatever computer platform it is that you've got, and you have exactly the same user interface to your file set, your data set, that's sitting right there in the same directory as all of the executables that make it work, that can be run on all the different operating systems that all give you the exact same interface. LaserBoy. LaserBoy probably does have a pretty steep learning curve, and it's hard to know why you would want to use LaserBoy until you really know what LaserBoy is and what LaserBoy can do. So hopefully, I think it's worth it to spend some time working with LaserBoy. And if you have questions, ask me. But if you use LaserBoy for a while and you get into it and you start to realize what it is and what it can do for you, then you can figure out how you can use that in your workflow, whatever it is that you're working on in vector space. So LaserBoy is a complex memory object. It's able to open the contents of any legitimate ILDA file into the memory of the computer, and then once it's loaded into the memory of the computer, it's able to display a view of that data set on a two-dimensional computer monitor in pixels. So you got vector data that's three-dimensional in space. You can look at it from any angle of rotation, anywhere you're looking at it, any direction you're looking at it from, and it'll render whatever's there. You can zoom into it, you can zoom out of it, you can pan left and right and up and down just by changing the camera settings, so to speak. But you can also change the data itself, because you have the data in the RAM. It's dynamic. You can do whatever you want to do with it. And that's pretty much what LaserBoy lets you do. LaserBoy is open source software, which means all the source code comes with the distribution. And I guess if you know something about C++, you might want to look there, because it is, the way LaserBoy works pretty much comes from C++, and the way it allows you to implement an object-oriented environment, a hierarchical set of objects, or coordinate and communicate with each other in the same space. Typically, when I start on a programming project, I like to start with absolutely nothing and build everything from the ground up. And that's kind of where LaserBoy started. I mean, I'd written all of the LaserBoy code, and I also wrote the API, EasyFB, that put LaserBoy into the video card. So, I mean, I literally wrote all of it except for the Linux kernel and the frame buffer support that it provides. And then somebody told me about SDL, which is a simple direct media layer, which is an API that's written predominantly for game developers, and it makes it possible to use a common interface to communicate to media devices like the keyboard, a joystick, a mouse, the monitor, a set of basic abstractions of things that you would find on any operating system. So you can write one set of code that communicates to the SDL interface, and then SDL handles the communication to whatever operating system it's actually running on. So that made it possible for me to write one set of code that I could compile, and people using Windows could use it, along with people who use Linux. What SDL gives me is the ability to open a window of a certain width and a certain height in pixels, and it gives me the address of the upper left-hand most pixel in that window. And I know that I can simply copy a bitmap that I've created in my code to that address, and it will appear on the screen inside the window. And that's true in all operating systems, which is, that's the beauty of SDL. It also gives me what key you hit on the keyboard, and whether or not you got the shift key down when you did that. And so I get keyboard events, and I know where to put the bitmap on the screen every time a keyboard event happens. And I also get timers, so that I can use whatever the system clock is to count milliseconds or microseconds within the code in order to do things like timed framed per second output when you're playing an animated set of frames and you expect them to show at a particular frame rate. Also, when you're playing a WAV file on the screen, it shows it to you at the same speed or the same rate it would appear if you were to be playing it into the sound card and into a laser projector. For me, LaserBoy is kind of like a place to go to. I can go there two ways. I can go there by looking at the code in a code editor, and I visualize what the code does in my mind, and I can alter it and add to it and fix it and find issues with it and fix them, or come up with a new idea and spend days and days figuring out how to implement that idea. And that's really what keeps me going, is the discovery of new things to do in this space. That's kind of important to me. It's like a collection, really. When I started putting LaserBoy together, I thought, this is cool. I can do some really nice stuff with this. And then it just kept I just kept realizing, well, I could do this too, and then I could do this other thing, and if I do that, then I have this other stuff to do, and it has just kept going along. And one of the things that's really driven it is working with other people who have started to use it to do things, particularly with DXF import and DXF import of multiple frames to be able to use 3D CAD applications to render to DXF file and then open them in LaserBoy and sequence them, turn them into something that is actually usable as color laser vector art, and being able to read and write plain ASCII text files. When I work with other artists who have projects in mind that LaserBoy has in some way at least gotten close to solving for them, when we exchange files, we exchange conversation about what they want to do and how they want to do it, it always makes LaserBoy so much better. And there's been so many things that have been added to LaserBoy because various artists have contacted me and said, hey, okay, this does this, but I need it to do that. And then I would work on it, and I'd get something done, and I'd say, there, now it does that. And now LaserBoy does that for anyone who wants to do that. So LaserBoy does a lot of things, and it's interesting that it is simply in the realm of files in and out. You know, you might think that's a limitation, but it's not. It just puts the LaserBoy application in a particular domain of applications. Color laser projection, I think, fascinated me right away because I realized it was a combination of two things that I really, really enjoyed. I'm a musician and a recording artist, so I was already pretty used to the idea of working with WAV files and working with digital audio. I'm also a visual artist with a lot of experience in computer graphics and programming. And color laser display is actually a combination of both of those things. It's a set of signals that are very much like audio signals that create a color visual image. And that was fascinating to me. Those two things come together to become one thing. Back in late 2003 when I got involved with laser display, there weren't very many people working with it. Most of the people who were directly involved with laser display probably worked in the entertainment industry for some production company that toured with a band, or maybe in an amusement park that had a laser display. So it was a very esoteric art form at that time, and not very many people had ion gas lasers and optics tables and polychromatic acousto-optic modulators and scanners set up in their basement. A few people did, but not very many people. So I guess one of the reasons why I was attracted to it was because it was wide open. There were so many things I could do that just hadn't been done yet. And so that was exciting, because I definitely like to come up with ideas, put it out there, and think, maybe I'm the first person that did this. I was born in late 1964, and I remember probably when I was about 10 years old, I was absolutely fascinated with the concept of a computer and what a computer was and what it did. And by the time I was 11 years old, I knew that I wanted to learn how to program in C, and I dreamt about working on a Unix computer, Unix mainframe. I mean, I'd seen the big stacks of printouts of the Snoopy calendars and all the cool stuff that you could do with computers, and I was absolutely fascinated by all of that. I got the Sinclair Zx81 that had 1K of RAM, and you could buy the 16K module that plugged into the back of it. And one of the first serious programs that I wrote was, it would plot spirograph images, which is like a polar coordinate system thing, on the display, which was, by the way, it was 64 by 44 pixels on a television, black and white television monitor. And after that, I got a Commodore 64, and I pretty much did the same thing, except I had two colors to choose from on a 320 by 200 pixel screen. Same thing though, plotting polar coordinate equations or parametric line equations or what have you. The kind of thing that is essentially associated with vector graphics, coordinate systems. That's always been my interest in computers and computer science is ways to use them to make art, to make designs, to create something visual or audible, whichever the case may be. I love math. I've always loved math, and I like to use math to find art. There's all kinds of infinite patterns and design possibilities for art that are deeply rooted in math. And working with three-dimensional vector coordinates in color, well, there's a lot of math going on there. So in LaserBoy, in C++, I defined a lot of my own data types, like the color, or the 3D short integer, or the vertex, or a list of vertices, or a list of colors, and all of these things, these objects, they have functions and arithmetic operators defined on them. So they all interact with each other in the realm of math. And with that math, I was able to discover how to do a lot of things that make it possible to convert three-dimensional color vector frame set into a working multi-channel wave file that could be used to control a color laser projector. It's not real time. You actually have to create the frame set in the memory, kind of like in a studio production sort of setting. You're making something that exists outside of time, and when you're done with the entire animated set, you can render it as a wave file, and then when you play the wave file, you get the laser show. So that's been my plan all along with LaserBoy. It's really never been a live streaming content environment. It's always been like a studio, a production tool to work with color laser vector art. I feel like if you use math to make art, the art has some kind of inherent proven substance to it. In other words, somehow or another, it becomes the solution set of whatever ideology or methodology went into it from a mathematical perspective. So it's a proof of concept. A finished piece works because mathematically it resolves. And that's kind of how I like to look at making art. So LaserBoy is art, the code is art, and the running application is art. And that's the perspective that I like to look at it from, is that this is my work of art, and it's a tool that allows other people to express themselves in this art form. Color laser vector display, or oscilloscope display, or vector video creation, or high resolution bitmap images of vector space. There's quite a few options, things that you can do in three-dimensional color vector space and its relationship to raster space using LaserBoy. And hopefully we can get enough of an overview of it that you'll at least feel comfortable enough to try it out and look for more information as to how to use it more effectively.